whole lives. And I didn't even hit record for people that were absent that day. That's the worst part of it all. I realized like halfway through, and then I was like, there's no point in hitting record now. $1,500 times 1. Oh my gosh. At the end of the day, it just can't handle anymore. It's like you guys, right? Plus 0.07 I'll just go really slow. To the n power with number of years is 6. And honestly, when you do this on your test, I would like you to write out what you're typing in your calculator, but then you should just be able to type it in your calculator and tell me how much money you have. I might just be talking and you can write it all down since it's all printed out for you already. 1,500 times 1 plus 0.07 to the 6th power. And remember, we're talking about money here. I got $2,251.10. Did you get that? And so we should round to 2 decimal places. I don't have time for that. That means I have to shut everything down and reopen it. Oh look, here we go. It just connected. Hooray! Oh look, here we go. Oh, I'm going. Anybody need help with their calculator? I need help with my smart board, but that's the point. 10 cents. 2251.10. That's what you should get. If you don't get that, let me know. And if you don't have a calculator, let me know. I'll give you one because you should be practicing typing this in your calculator. Because during a test, I will not help you with your calculator use. That's why I try to do these in class so that you will use them and let me know if you have a problem. So what if it's compounded more than just once a year? Then we have a different formula. This formula works even if it's once a year because you can just plug in 1 for K. Again, all this little stuff is just telling you what it is. But the same idea, the amount. Oh, look, it does that, but it won't write the letter. I'm just going to type it, kids. So we'll write like this. The amount is the principal times 1 plus R divided by K, instead of just R, and then instead of just to the n power, we say that's to the K T power. So P is still our principal, R is still our interest rate. K is now the number of compounded K times a year, and T is the number of years. If K is 1, we have the formula that I just gave you. So notice this is the same problem that I just gave you, except for now, instead of compounding it annually, we're going to compound it 4 times a year. So you think we're going to get more money or less money if we compound it more often? More money. Someone last hour said that last year in Algebra 2, they were very excited to see how much money they could make. And then Mr. McClure informed them that you don't really get to make this much money, which is kind of true most of the time. But if you have a credit card, they like to compound your interest all the time so that they can charge you lots of money. When you guys watch that video, this is what happened. This was this day. I'm about to just give up. Should get done before me this time. 1 plus 0.07 divided by 4 times a year. What else could they say besides 4 times a year? Compounded quarterly. That's how most savings accounts are compounded. Parker has a savings account, and every quarter I get a little statement saying he earned 3 cents in interest. That's 12 cents a year, kids. He's earning charge. To the 4 times 6. What? Does he have like $1 in his savings? No, he has over $1,000 in savings account, and he still only earns 3 cents a quarter. So that's how little Because every time he gets birthday money or stuff like that, we make him at least put half of it in. And when he was 1, he got like $150 for his birthday, so we just put all that in there. He gets ridiculous amount of money from grandparents, and he's still young enough. He doesn't fight me on putting it in the bank. So, and I put so much. I think I put $10 a week in there. So I put $500 in it, I guess, a year. Try to save up for college. He thinks it's his money though, because I'll show it to him sometimes. Like, look how much money in your savings account. And then he'll break something or about break something. I'm like, Parker, if you break this, you're gonna have to buy a new one. Well, how much does it cost? And I'll tell him, I have that much money. And I'm like, no, that is for your college. He's rough. If I'm doing this on my calculator, I'm just gonna go ahead and multiply 4 times 6 together and say that's 24. So I don't have to put a parenthesis in my exponent. But I think we should get almost the same as the last one, right? Just a little bit more. I got $2,274.66. Yep. Some of your homework tonight is this easy, where you're just typing it in as long as you know what formula to use. Anyone have a question on that? This next one, this is kind of just overview of the 2 types of formulas that you need to know. When interest compounds K times per year, that's what we just did. So if you want to write it again, you can. If you don't have to. But I'm going to write it again. A equals P times 1 plus R over K to the KC power. Anytime it's compounded so many times per year. It could be annually, it could be monthly, it could be daily. Anytime it says so much per year, you use this formula. The other formula is what if it compounds continuously, which I always have a hard time thinking about. Like, so what does that mean continuously? Like, it never stops compounding. That's when we get to use our friend E. And if I write this, maybe you'll remember this formula. A equals PE to the RT power. When I was in school, we always called that PERT, because it spells PERT. If you see the words compounds continuously, it means you get to use this formula. And all you have to know is the principal, what you started with, the interest rate, and the time, because you don't have to worry about how many times it compounds, because it compounds continuously, and you just use your calculator, and you get how much money you have. And again, yes.
Last year, how should we figured out how much Bill Gates makes because his interest continuously. It's a lot. I don't know exactly.
How do I get my interest to compound continuously?
You have to have a certain amount of money.
That's never gonna happen. But it is true. Maybe my YouTube channel will make a thing. My favorite YouTube guy is Patrick JMT, and he posts a lot of videos. And people always comment about like, oh my gosh, you saved my life. You helped me pass calculus. And someone writes, you don't get paid for this. And he said, well, I get a few cents for my YouTube stuff, but I kind of wonder how much you make, because I feel like it's not very much. I clicked on it once because it said I can monetize my videos. But one, nobody watches them, so I don't really think I need to. But it's kind of, I don't like those big agreements that you have to like, that's so long that you don't even read it all. Like, I'm worried about what I'm agreeing to, so I backed out of it and decided not to do it. But one thing I had to agree to is that I wouldn't click on my own videos to make money. So just me going and clicking on it like 100 times a day. I had to agree that I wasn't going to do that, and I was like, I don't know if I can agree to that.
You should just tell your kids to do it.
I know. Give extra credit for every 100 times that you watch my video. Again, as a decimal here, right? So that should be 0.054. And we're going to put this in for 6 years. And again, that's a 6. When I do this on my calculator, when you hit E, it automatically puts that caret there. Just type 0.054 times 6. Like, don't close the parenthesis after 0.054, or it's not going to take it off the exponent. So something keeps happening, because it just keeps acting like it's just now plugging in every time. My smart board is ridiculous. This is life. I should sit here and teach every day. I got 1728 said no. Oh, there you go. Anybody else not get that? They think Chris good. We had a big talk with Sawyer today, but he wasn't listening to us. Our quote says, playing on a torn ACL isn't good. Anonymous. We're going to see if Sawyer notices tomorrow. We had a big talk. So that's pretty easy, but we're in Precalculus, so you know your whole homework assignment can't be that easy. We've got to be able to solve some of these too. So let's look at some more stuff here, like this. Joelle invests $8,000 into her retirement account with a 9% interest rate, compounded monthly. How long will it take until this single payment has grown in her account to $16,000? So a lot of your homework today, you're just plugging in just like we just did. Pretty easy to do. You just need a calculator. But then you're going to have stuff like this that you're trying to solve for how long. Of course it's going to work when I do that. How long will it take? Which means you're looking for time, right? So that means you should be able to take those formulas, plug in everything but time. Since it's compounded monthly, we're not using per, right? We're using the other one. So we're going to use the formula A equals P times 1 plus R over K to the KT power. And you should be able to plug in every letter there but T, and then we can use our skills to solve that. A is the amount that you have at the end of the time, which is $16,000. P is what you start with, which is $8,000. R is your interest rate, which is 0.09. K is how many times it's compounded, and monthly would be 12. Still 12 up there for K, and T is what I don't know. This kind of looks bad, but it's really not that much to do. If you just take a couple steps, it looks a lot better. For me, step 1 is I'm going to divide by 8,000 instead of distributing, just because I can't distribute anyway because it's all to a power. So if I divide by 8,000, do you agree that that goes down to 2 over there? And the other thing I always recommend doing is type that in your calculator. It's going to be a decimal, but type it in because then you don't have to deal with the parentheses later. Plus 0.09 divided by 12 is 1.0075 to the 12t power. And you did stuff like this on the worksheet, hopefully on the worksheet you did this. How do you solve something that has an exponent with the letter? How do I get that letter out of the exponent? You L in it or you log base 10. I like to L in it. So we are going to L in both sides because that's the only way that you can pull that out front. And I don't know about you, I don't know, maybe I'm not good at showing my work. But when I L in it, I automatically pull that 12t out front. Like I always write this as 12t L in of 1.0075 because I want to just pull that out already. Are you okay if I do that? And once you do that, all you're doing is solving for t now. And this is multiplication. So you can do this in 2 steps or you can do it all in 1 step. If I'm trying to solve for t, do you agree I could divide by 12 and I could divide by ln of 1.0075 and that's going to give me t all by itself? And in second hour, someone said, well, can I divide by 12 and hit enter on my calculator and then divide by ln of 1.0075? You can. It will get you the same answer. You can even divide by ln first and then 12, as long as you divide by both of them. If you're typing this on your calculator all at once, though, you need to make sure you put that whole thing at the bottom because your calculator will do order of operation. So if you ever put more than one thing at the bottom at once, I just say you should put a parenthesis around it just to make sure that you get the right answer. Also, make sure you close the parenthesis around that ln to say you're just taking ln of 2 divided by parenthesis 12 times ln of 1.0075. And I 7.73-ish as my answer. You with me on that? So here's the extra set that we can do because we're super smart. That's years, right? 7.73 years. Which means we could change that 0.73 years to months, right? Why would we want to do that? Here's why. We want to know when exactly will she get this much money, at what compounding. Like if your bank account compounds quarterly, then every quarter you get a statement saying this is how much money you have. This one compounds monthly, so that means every month Joelle would get a statement. I want to know 7 years and how many months until she gets this much money. So how can I change 0.73 years? What would I have to multiply by to change that to months? Think about your good old chemistry years. Yeah, chemistry years. In 1 year, how many months do you have? So can you just take that decimal times 12 and it would tell you how many months that is? You get like 8.76 months, which means at what month will she have that much money? Will it be 7 years and 8 months, or will it have to be 7 years and 9 months? We'll do another one in a minute to talk about this rounding issue. For me, when I looked at this, I didn't do this. I just saw that 0.73 was really close to 0.75, and 0.75 is 3/4 of a year, and 3/4 of a year is 9 months. So, like I thought about it being the third quarter, but that's just my mind in quarters, right? So, think about that today as you're doing it. If you look in the back of the book and it has that and you have decimals, then maybe that will be your reminder to do that. Do another one? Let's do another one. We like to ask you how much time it takes to triple or double an investment. And so this one says, what interest rate compounded monthly is required for an 8,500 investment to triple in 5 years? Again, if you get stuck on these or you're not sure where to start, to me, step one is figure out what you're solving for. And on this one, we're solving for interest rate, which means, again, I should be able to take my formula, A equals P times 1 plus R over K to the KT power. And I should be able to plug everything but R in there. P is what I'm starting with, 8,500. So what is A? Because you just tripled this, right? Right. So, think about that as that's 3 times 8,500 because you're tripling it, or whatever that was, 25,500. Tripling it. If you were doubling it, you multiply by 2. Again, we're compounding monthly here. But I actually know what T is this time, so I could say 12 times 5 out there. We don't even need the ln in this problem because there's nothing in the exponent that we're looking for. We're actually just looking for R there. We just have to figure out how we can solve that. If I divide 8,500 over, I kind of like to write it like this because I can think about those 8,500s canceling out. In degree, I'll just be left with 3 there. And I'd have 1 plus R over 12 to the 60th power. Would you want to FOIL this out 60 times? That would be awesome, right? I can't separate this because it's all to the 60th power. What can I do to get rid of the 60th power, Savannah? Oh, well, I wasn't going to ln, but I guess you could ln because you're saying we could ln and then pull the 60 out front.
Yeah, or take the 60th root.
Yeah, I totally just took the 60th root. But yeah, Philip in second hour said that he LN'd both sides, and it still gets the same answer. So it's whichever you see, and it would work if we LN both sides now. Could we pull that 60 out front? Then we'd still have to figure out to separate that. But honestly, I just took the 60th root of this, which kind of seems weird to do, but it works, right? The 60th root of 3. That's also the same as taking it to the 1/60th power. 1 over 60, that would also work. My calculator, I have a button I think that looks like this. You have to hit the root first, and then you hit that button, and then you hit that number, and you would get the decimal. But I'm going to wait to do my decimal till the end, because I don't like carrying all those decimals all the way through. But if I did that over here, do you agree that that would just give me 1 plus r over 12? And you can write the decimal if you want, but I like to wait to the end, so I'm going to write that as the 60th root of 3 right now. Yes. It would, I think so, but if we included the negative, then we would get a negative answer, and we don't want a negative answer. Does that make sense? But yes, technically, because it's an even root, we would want to say plus or minus, just like we do when we take the square root. But because we're talking about interest rate here, that's why we can throw it out. That's a good question. To solve the rest of this, do you agree I can subtract 1, multiply by 12? So I wrote this on my paper. The 60th root of 3 minus 1, that would equal r over 12. Then I can multiply both sides by 12. So I always like to wait till the end to use my calculator. I know sometimes you don't. But on my calculator, I wrote 12 times the 60th root of 3 minus 1. We're talking about interest rate here, so you should get a decimal smaller than 1. If you get something bigger than 1, we have a problem, because that's like over 100%.
If we were to do the interest rate, do you want us to round to nearest whole?
I did 2 decimal places after, actually. Let's see if I can get this to work. Root of 3 minus 1. I got 0.2217. And I use 4 decimals because when I move it over 2 places, do you agree that that's like, say, 22.17% interest? Which is exactly what you get when you LN. Philip LN to begin with. He LN way up there. Somewhere, I don't know. And he still got the same answer. That's a pretty high interest rate. That's like something you would see on a credit card interest rate. Because if you don't pay your credit card, you could see your amount tripling in 3 years, 5 years, whatever this was. That's why you should pay off your credit card bills. Okay. What else do I like to give you this? What if they don't give you an amount? Same idea. Let's look at one more. My last one. On your homework today, I think there's like a chart, if I remember correctly, and like there's certain things missing, and one of them is always how much time does it take to double, and people always think they can't do it if you don't have the amount, but you really can. So I just want to make sure we look at this one. Determine how much time is required for an investment to double if interest is earned at the rate of 5.75% compounded quarterly. How many times is quarterly again? So again, let's just write this out. A equals P times 1 plus R over K to the KT power. We're trying to find how much time, so yet again, I should know everything but time. But people struggle with this because they say they don't tell me how much I start with, so how am I supposed to figure out how much I have when it doubles? If P is how much I start with, how much do I have after it doubles? Right, and you don't have to know what P is, just like on the last one when I wrote 3 times 8,500. You can just do that, because then you can divide by P and it just cancels out every time. So if I'm talking about how much it takes to triple, you don't have to actually know what P is to do that problem. But everything else we do know. Quarterly, so that's 4, so the 4t power. And if you see a letter in your exponent, you should know at some point you need to LN both sides. So why don't you get a head start on me on that one? You can divide the P out. If it was me, I would put this on my calculator and write all those decimals down, see if you can LN both sides, see if you can get an answer for time, and then we'll talk about how we round it for the quarterly. Again, really important that you're typing this in your calculator correctly. Again, notice this is exactly how we did, not the last one, but the one before where we're solving for time. You plug it in, divide that number over, LN both sides, pull that out front, divide it. Every time, it's the same thing, the numbers just change. And you should get a time of 12.14 years. And we could change 0.14 to months, but for me, when I think about quarterly, do you agree that that happens at 3 months, 6 months, 9 months, and 12 months? So we can change it to months if you want, but to me, when I look at 0.14, is that even to 3 months yet? So in my head, I think about, oh, well, that's not even in 3 months, and if it's quarterly, I got to round up to the first quarter, which means I know it's going to be 12 years and 3 months. If you change 0.14 to months, you get 1.68 months, but you can't just round that to 2 months. You have to round it to how often it's getting compounded. Does that make sense? If it was getting compounded monthly, you would just round up to the next month, but it's only getting compounded quarterly. If it was getting compounded yearly, like once a year, you'd have to round that up all the way to 13 years because that would be the next time that it's compounded. So you have to pay attention to the compoundings, and we'll look at that a little bit more tomorrow. Tomorrow we'll do more exciting formulas like payment for a car, and what if you have a down payment, and how do you take that into consideration, and mortgage payments, and they get a little bit more exciting tomorrow. But today, hopefully, maybe isn't so bad. Okay? That's it. Or no. This is 3-6 day 1. We only have tomorrow in our review, so if you're behind in homework is due this week when we have our test. So I'm actually going to make you turn it in the first day, and I'll grade it and give it back to you before you leave that day, so you can have it to study again. But I'm not going to make it due the second day, because then that means you won't do homework. So.